Okay, folks, here is the second half of this video. What I want to demonstrate in this case, the one major difference between problem 8 and problem 12 is the fact that you will not have the population standard deviation to use. So let me just make a key point here before I go any further. The only change that you're really going to see here is the change in the test statistic. And that is the fact that you're going to use the sample standard deviation versus the population standard deviation, though the test statistic looks a little bit different. And notice that it will be a t distribution versus a z distribution. So let me just kind of qualify that up front, and we'll go through this. So again, 13 is assigned for you, so I'm going to go through 12. The management of White Industries is considering a new method of assembling its golf cart. The present method requires a mean time of 42.3 minutes to assemble a cart. The mean assembly time for a random sample of 24 carts using the new method was 40.6 minutes, and the standard deviation of the sample was 2.7 minutes. Using a 0.10 level of significance, can we conclude that the assembly time using the new method is faster? So that's the key statement here, and realize that if it's a faster method, it will take less time. So that's important as we look at the hypotheses. So again, I've taken this screen capture out of your book, and again, just re-emphasizing the fact that this is very process-driven. Just make sure that you're kind of adhering to this process, and I really don't think you can make a mistake here. So again, based on the question that's being asked here, using the 0.10 level of significance, can we conclude that the assembly time using the new method is faster? So right now we will assume it's not. So the null hypothesis is the average or the mean time to assemble the cart is at least 42.3 minutes. And the alternative is to test whether we can, or the data will tell us that statistically it is significantly less than 42.3 minutes. So the level of significance, again, 0.10. Notice that you have a sample of size 24. So given that this is a t distribution with 23 degrees of freedom, and again, a left tail test, right? You can see this is left tail based on the the alternative hypothesis, the population mean being less than 42.3. So this is a one tail left, and let's see, with 23 degrees of freedom, 0.10, you will find in the t table that the t critical value is 1.319. So let's see, with those two things said, going along with step one here, the key phrase is, can we conclude that the assembly time using the new method is faster? And I make sure we realize that that is less time. Step two, which I just went through, this is a t distribution because we do not know the population standard deviation. And again, with 23 degrees of freedom at 0.10 level of significance, that critical value is minus 1.39. So if you go through and compute the test statistic in step three, that is right here, 40.6 minus 42.3 over 2.7 divided by the square root of 24 gives you negative 3.085. So again, if you think about the rejection region idea, let me just go back here. If this was a t distribution at minus 1.39, and then you have a test statistic of minus 3, you are clearly over here in the rejection region. So we are going to reject the null hypothesis and assume that the mean assembly time is less than 42.3 minutes. And then if you wanted to go through, obviously you could go back to the t distribution and find the p-value if you wanted to verify this using the p-value approach. That would be, again, in a t distribution curve with 23 degrees of freedom and a test statistic of minus 3.085. What is the probability of finding a value or finding a test statistic more extreme to the left, meaning less than negative 3.085? And I am quite certain you're going to find that it is less than, probably quite significantly less than 0.10. So either way, you would be led to the conclusion that you should reject the null hypothesis. let me just, while I'm here, since both of these two tests of hypotheses had test statistics that led us to a conclusion of rejecting the null hypothesis. Let me just go back here and just, since I have this little graphic here, when would we fail to reject the null hypothesis, which would be the alternative way to conclude a test of hypothesis? If the test statistic is computed and it does not fall in the rejection region, or if the p-value is greater than alpha, then the conclusion would be that we fail to reject H naught, and we just would leave the conclusion at that point, and we're going to continue to assume that the mean, population mean, or the population parameter or population proportion is as stated in the null hypothesis, right? So those are the two outcomes that you will get from the reading, and again, they're very straightforward based on being able to place your test statistic within a representative distribution or go through the p-value computation. Okay, so the final thing that we want to talk about here, I thought we were dealing with bus data, but it's actually the baseball data. And actually, I'm sorry, it is. I thought we were dealing with the bank data, but we have baseball data and bus data. These two problems you will do based on the data from those two sets. I have underlined some key phrases for you, which I think will be very helpful for you. As again, remember, this is very process driven. Just go through steps 1 through 6. I don't think you can steer yourself wrong if you do that. But if you get off track, please let me know, and I will make sure that we get you back on track. So again, let me just state here very quickly to kind of wrap this up. Make sure that you follow the 6-step process. If you do, you cannot go wrong. Again, I think the most challenging thing for you to do is to carefully state the hypotheses. And once you have done that, again, making sure that you have the equality in the null hypothesis, and then you'll be ready to go. And I will make sure that, I just want to say this to make sure that everybody, when you go into these data sets and you compute the mean and the standard deviation, we talked about how to do those things back probably week 2 in Excel. But if you forget how to do that in Excel, how to compute population or sample standard deviation, let me know. Actually, I think I can, let me see if I can add it right here. Remember, sample standard deviation would be equals STDEV dot S, and then whatever your data is, that would be sample standard deviation. And if you wanted population standard deviation, STDEV dot P, and then whatever your data is, and that would be the population. So thankfully I was able to add that, not population, I was able to add that. So that's the syntax that you will use in Excel. The only difference between these problems and the two that I just did for you is you're going to have to go through here and find the sample or the statistics, I should say in both cases, but that's very easy with Excel. And then if you follow the process, just again, be careful on your stating your hypotheses, and use, assume that these are all going to be parameter values. That way, there's no question about how to handle that. And I think it should be pretty straightforward. So again, not a lot of Excel work this week. A lot of this is kind of manual crank and understanding this process. So if anything seems uncomfortable as you go through these, please don't hesitate to let me know, and I think we'll have another good week. So take care, and I look forward to seeing your work. Bye-bye.